Alrighty, let's take a look at question number 5. Okay, question number 5, we're being assessed on how to determine the intervals of concavity of a function. Where is it, concave up or concave down? Okay, so to get us started, let's write down the formula that's going to help us to solve this problem. So all you just need to remember is that f of x is concave down on an interval, let's say AB, if the second derivative is less than 0 there. Okay, so if the second derivative is negative, you have a downward opening concavity. If the second derivative is positive, then f has an upward opening concavity. So in this particular case, we're looking for where f is concave down. That's why we're looking at where f double prime is less than 0. All right, so just to help you recall, we are going to use an easy way to remember this is your fun chart, right? So let's look at the fun chart real quick. So f concave up, concave down, f prime increasing, decreasing, f double prime positive or negative. Okay, so this is very important. You can use f prime or f double prime to determine the concavity, okay? If you know the behavior of f prime, you can determine the concavity of f. All right, this particular row right here where f prime is increasing or decreasing is helpful when you're dealing with a graph. If I give you the graph of f prime, then you can determine where it's increasing or decreasing and easily determine the concavity of f. But when you're given a function of f, you want to use the second derivative because you can easily determine the sign of the second derivative around the critical values of the second derivative. Alrighty, so remember this one is use f double prime algebraically, and then use f prime graphically when you are finding the concavity. F double prime, you can use algebra or graph, it doesn't really matter, but this is faster for algebra, okay? Okay, now let's see. Where are we at? So we're starting with the function f of x equals 6x to the 5th minus x to the 6th. Since this is an algebraic representation, we need to find the second derivative, okay? Find the second derivative and then look for the critical values of the second derivative and figure out what intervals around the critical values do we have a negative sign for the second derivative, okay? All right, let's do it. So we're going to be using the power rule twice here. So the first derivative, f prime of x, is 30x to the 4th minus 6x to the 5th. Do it again. F double prime of x is 120x to the 3rd minus 5 times 6, 30x to the 4th. Okay, so we need to find the critical values of f double prime. Next, so find critical values of f double prime. What on earth is that? What is the critical values? The critical values are basically where whatever you're looking for the critical value of is equal to 0 or d any, okay? So we're looking for where f double prime of 0 is f double prime of x is equal to 0 or f double prime does not exist. Those are critical values. So we just take, so let's do the first one. Let's find where f double prime of x is equal to 0. So we have 120x to the 3rd minus 30x to the 4th. Solve this algebraically for x. Okay, so set equal to 0, solve for x. What can we factor out? We can factor out the GCF, 30x to the 3rd, which leaves us with 4 minus x equals 0. Using the zero product property, we set both factors to 0 and solve. If we solve the first one, just divide both sides by 30 and you have x to the 3rd equals 0. take the cube root of that, and you have x equals 0. Your first critical value is x equals 0. And then for this one, just add x to both sides. X equals 4 is your second critical value. Where is the second derivative non-existent? This is a polynomial function, so it's smooth and continuous, okay? The denominator is 1. So you're looking for where is 1 equal to 0? It's never. So this function is defined on the entire real number line. So we don't have to bother looking for where it does not exist. We just look for where is equal to 0. Okay, we have our critical values. Now we're going to use our sign chart to determine what the concavity of the function is about the critical values. All right, so we don't have any constraints on our interval, so we have a real number line. Critical value number 1 is 0, and then the second critical value is 4. So let's put our partitions up so we have a clear visual restriction on what we're working with. Okay. Now, what we're looking for is the sign of f double prime. Ladies and gentlemen, I'm going to use the factored form. Okay, it's much faster. I'll tell you why in a second. So sign of f double prime, running out of space here. So that is, let me see, 30x to the third times 4 minus x. Okay, so the sign of f double prime, that is going to tell me the behavior, namely the concavity of f. Okay, all right, so we have two intervals, actually three, sorry, we have interval 1, 2, and 3 to test. So we need to pick numbers that satisfy the interval. So for the first interval, let's use x equals -1. For the second interval, x equals 1. For the third interval, x equals 5. Ladies and gentlemen, all we care about is the sign. What does that mean? You do not have to evaluate the expression completely. You just have to figure out what the sign is and go from there. Okay? All right, so for x equals -1, we have 30 times x to the third. What is the sign of 30 times x to the third? What is it going to be when you plug in -1? Since you're raising -1 to an odd power, is going to be negative. So it's going to be negative for that. And when I put in negative here, 4 minus -1 is positive. Notice I didn't do the work. I just figured out the sign, okay? Because time is of the essence here. Minus times plus is minus. That tells us that f is going to be concave down on this interval because f double prime is negative. All right, let's move to interval 2, x equals 1. When you plug 1 here, 30x to the third, that's going to be 1. I'm sorry, positive. When you plug 1 in here, 4 minus 1 is 3, which is positive. So your sign is positive. F is going to be concave up because f double prime is positive. And then lastly, for 5, you plug in 5 here, is going to be positive. 4 minus 5 is -1, so it's negative. Plus times minus is minus, so f is going to be concave down. So do you see what the answers are? F is concave down on two intervals. F is concave down on -infinity to 0 and 4 to infinity. Because why? Because the second derivative is less than 0 on those intervals. Alrighty? So the answer to problem number 5 is option A. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for your exams or calculus in general, do give us a like. Your positive feedback is very, very helpful to us. Do not forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions or comments, just post it in the comment section below. If you'd like to gain access to our epic formula sheet and other valuable resources to help you do well on the AP exam, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.